This is the lecture for section 6.4, MAC 1105, College Algebra. So in this section, we're going to be talking about logarithmic functions. And so there's a couple of rules that we're just going to introduce here. So y is equal to the log base a of x if and only if x is equal to a raised to the y power. So if you notice that in each one of these, this is the base. And then here, as an exponential function, is also the base. So that's one way to kind of remember where does that go. So again, y is equal to the log base a of x if and only if x can be defined as a to the y power. Now, a is greater than 0, a cannot equal 1, and x is also greater than 0. Now, the domain of a log function is from 0 to infinity. 0 is not included. And then the range is all real numbers. So again, just to kind of repeat that, if y is equal to log base a, right, if and only if x is equal to a to the y power, the domain of x is between 0 and infinity, and the range of y is between negative infinity and infinity. The next one is a natural log. So if y is equal to the natural log of x, or y is equal to the natural log of x, if and only if x is equal to e raised to the y power, and e is a constant. And then the last one, y is equal to log of x if and only if x is equal to 10 to the y power. So if there's no value there, so if y is equal to this, we just don't put the 10. So without the 10 as the base, that's by definition, that's what it is. So for number 12, we're going to rewrite it as a log function. So the first thing that I see is that 4 is my base. So it's going to be log base 4. And then, so log base for 16 is equal to 2. So basically, the 2 and the 16, if you think about it, it's just going to switch sides of the equal sign. So for number 14, a to the third power is equal to 2.1. So my base is going to be a, and then it's going to be 2.1 is equal to 3. So that's probably a good way to remember. So just remember that log base a of x means that x is equal to a to the y power. So for number 20, we're going to write it as exponential function. So it's going to be 3 raised to the negative second power is equal to 1/9. And so again, 3 is the base. We just kind of switch the sides of the equal sign with the values. So for number 24, it's going to be 2 to the x power is equal to 6. Now, they're not asking us to solve it, so we're not going to go ahead and solve that one. We're going to solve those later on. So for number 40, they're asking us for the domain. Now, in this scenario, x minus 1 has to be greater than 0. And so we're just going to solve that. X minus 1 is greater than 0. X is greater than 1. And so my domain for this particular one is O values x such that x is greater than 1, right? An interval notation would be 1 to infinity. So that's how you find the domain of number 40. So for number 46, what they're asking us to do here, again, is find the domain. So that requires that the expression inside is greater than 0. Now, we know that the function here, g of x, is undefined when x is equal to 5, right? So we're going to go ahead and use that in order to find out whether it's positive or negative, right? Remember, it has to be greater than 0. And so we're going to go ahead and create an interval. So negative infinity to 5, and then 5 to positive infinity. We're going to go ahead and use a test point. So that's going to be 4 and 6. And so if I plug in 4, right, I get 1, 4 minus 5. It's going to be 1 over negative 1, which is going to be negative 1, right? So that's going to be obviously negative. If I plug in 6 into the expression here, so it's going to be 1, 6 minus 5, 1 over 1 is equal to 1. So that's 1. So that's obviously going to be positive. And so remember that it has to be greater than 0. That's what we said here at the beginning. So then the domain for this is all numbers x such that x is greater than 5. Or in interval notation, 5 to infinity, since we already had it right there. All right, number 90, we're going to go ahead and solve for x. And so here we're going to use some of the properties that we learned before, but there's several ways to solve these particular equations. And so what we're going to do is we're going to look at 90. So we're going to go ahead and rewrite this as 5 to the third power is equal to x. 5 to the third power is 125. So then the solution for this particular question is x is equal to 125. We're going to do the same thing for number 94, right? And so it's going to be x to the third power is equal to 1 over 8. And so we're going to take the cube root of both sides, right, to get rid of that exponent. So x is going to be equal to the cube root of 1 over the cube root of 8, which is 1 over 2. So x is equal to 1/2, and my solution for number 94 is 1/2. So the next one that we're going to do is number 100. And so again, here we're going to do the same thing. We're going to do 6 raised to the 5x plus 3 is equal to 36. And so you remember that if, let's do this. So if a to the u power is equal to a to the y power, then u is equal to y, right? So we're going to find the same base. So then this is going to be 6 to the second power. This is going to be 6 raised to the 5x plus 3. We can drop the base. So 5x plus 3 is equal to 2. And, hold on a second. And so we're going to solve for x. So here we're going to subtract 3. So 2 minus 3 is negative 1. And so x is equal to negative 1/2. So the solution set is negative 1/2. For number 102, what we're going to do here is we're going to say, okay, so we know before we said that if y is equal to the natural log of x, then e to the y power is equal to x, right? So then in this case here, we're going to say, we're going to take the natural log of both sides. So it's going to be negative 2x is equal to the natural log of 1/3. And so x is equal to the natural log of 1/3 over negative 2. And so the next thing that we're going to do here is we're going to, basically we can leave it this way, but let's do it this way, which would be a little easier, I believe. So let's say negative 2x is equal to the natural log of 1/3. And so negative 2x is equal to the natural log of 3 raised to the first power, right? Which means that, so remember, so the natural log of x raised to the r power is the same as r natural log of x, right? So it's going to be negative 1 natural log of 3 equals negative 2x. So x is equal to the natural log of 3 over 2. And so that's how you do number 102. So 106, we're going to go ahead and solve it the same way, right? So we're going to say that 5 to the second power is equal to x squared plus x plus 4. So 25 is equal to x squared plus x plus 4. I'm going to subtract 25 from both sides. And when I do that, I get negative 21. Now we can't factor that, so we're going to go ahead and use the quadratic formula. So x is equal to, so in this case, a is equal to 1, b is equal to 1, and c is equal to negative 21, right? And so here x is equal to negative 1 plus or minus 1 squared minus 4 times 1 times negative 21 over 2 times 1. So negative 21 plus or minus 1 plus, and this is going to be, so 4 times negative 21 is going to be 84 over 2. So negative 1 plus or minus square root of 85 over 2. And so then the solution set for this will be negative 1 minus square root of 85 over 2, and negative 1 plus square root of 85 over 2. So I'm going to leave 110 as extra credit for you guys, and that's the end of 6.4. Thank you.